This video will demonstrate how to use the Allegro symbol editor to create a footprint. Currently the Allegro PCB Designer is up with an Allegro design.brd open, so we're going to need to start a new drawing for our footprint. So we'll do File, New. Since I want to create a footprint, I'm going to scroll down here to our drawing types and select Package Symbol. I'm going to give that a name. We're going to do a dip 16, so we'll give the name something clever like dip 16. So I have here a blank canvas on which I can start creating my footprint. So first we might want to set our drawing extents and parameters to make sure that this drawing is set up correctly. So I'll do a right mouse button, Quick Utility, Design Parameters. Let's go to the Design tab. Probably don't need a C-size drawing. I'll just go down to an A. I want accuracy of 2. In the extents, I want to make sure that I have my 0, 0 someplace a little bit up and to the right, so I can add pins and outlines below the 0, 0. So minus 3,000, minus 3,500 probably is correct, and I'm okay with that. So we'll okay that form. So let's add some pins. In order to add pins, we're going to do a layout, pins. The options window, again, always important. Take a quick look at it. The top fields, I can add either a connect pin or a mechanical pin. Difference is a connect pin has a pin number, mechanical pin does not have a pin number. So if you put a mechanical pin down, you will not be able to assign a net name to it because there's no pin number. Next field is the pad stack. That's the pad stack name to enter. I can either type a name or select the pad stack browser. It'll give me a list of all the pads that I can find in the pad path. I'm going to use a 62C38D. If I can find it, down the bottom right hand corner we'll say using 62C38D.pad. Let's move my world view window over a little bit. You can see our command line a little better. All right, moving down, I can add this either rectangular or polar. Polar will be used for circular footprints, rectangular for arrays. We're going to do arrays, we're going to do rectangular. X and Y columns, since I'm going to do a dip in the vertical orientation. I'm going to add 8 pins down since it's a 16-pin dip. I want them spaced 100 mils apart, and I do want the order down. I could rotate the pad stacks if I want to. In this case, I don't need to. The pin number is going to be 1. I can increment by something different. It's going to be 1. The text block, this is the size of the text that's going to be for the pin numbers. I can use 1. And the offset says, when I put the pad down, how far does the text of the pin number offset from the pin? So in other words, this way it's going to be 50 mils to the left. If I zoom in some, you can see that pad's attached to my cursor. I'll select there. I now have 8 pins placed down, space 100 mils. Do right mouse button, done. I probably wanted this pin to be the origin. This is my origin marker. For through-hole dips, typically I want pin 1 to be the origin. So I'm just going to do a setup, change drawing origin. Move my mouse over that pin, but just to make sure I get that pin as the actual origin location, I'm going to do a right mouse button, snap pick to pin. Guarantees that it snaps that to the pin. Now we can see I'm at 0, 0. Okay, I have half my pins put in. Let me put the other half in. Layout, pins. I'm going to add 8 pins, spacing 100, but this time I'm going to go up. All right. Notice that it automatically set my pin number to 9. And remember that my last pin I put in was 8, so it incremented up by 1 to 9. I'm going to offset my text 50 mils to the right. So I'm just going to add 50 there. Now, I could just select where I want this pin to go, but I can also type on the command line down here. So I'm going to type in X, which means I'm going to type in an absolute coordinate based upon the 0, 0 of my design, which is pin 1. So the X coordinate wants to be 300 mils to the right. And the Y coordinate is going to be minus 700 mils down from the 0, 0. I'll hit the Enter key and it put in 8 more pins upwards, space 100 mils. That's not quite what I wanted. I would probably like to have pin 1 be a square pin to indicate the pin 1 location. So let's go use the Tools, Pad Stack, Replace command. Again, let's look at my options window, the old pad stack name. Rather than typing the name, I can just select on that pad, it will fill it in. The new pad stack name, again, I'll use the browser. It will look at my pad path. I want to use 62S38D. Now I don't want to replace that on every pin because it would change all of them, so I'm just going to change the pin number here to 1. So now I'm going to change this circular pin to a square pin on pin 1 only. I'll hit replace, made the change, right mouse button, done. All right, that's the configuration for my pins. It's looking good. Let's move on. Maybe we'll add a silk screen in next. Silk screen is just a series of lines, so I'm going to use the add line command. Again, let me check my options window. I want that to go on the package geometry class because this is associated with the footprint of the package. Since I want to do my silk screen first, I'll go to silk screen top. Probably want to put a line within here, something that's meaningful. I really don't want it to go in at 0. Let's zoom in here a little bit and let's start adding in our silk screen. That's kind of not a very good place for it to be. Probably something's wrong with my grids. So let's go into Setup, Grids. Remember, it's going to use my non-etch grid up here. 100 mils is probably a little bit too big, so let me just change that to a 25 by 25. Let me turn my grids on. All right, let's try this again. Let me go to my Add Line command. Everything gets saved there, so I'll start drawing that in. That's a little better. That's a series of lines. I just clicked with my left mouse button. Might be nice to have a little notch up here to indicate pin 1 again up here. Let's use the add arc with radius, checking my command line. Pick arc center point. It's right there. Pick arc start point, then pick the end point. All right. I probably didn't want this little segment in here, so let me delete that out. Let me go into delete command. I'll come over here. It's going to delete the entire line segment out, my entire silk screen top out, except for the notch. I didn't really want that. Let me do an all off, turn on other segments, move my mouse up to here. It still wants to pick this entire line up. So what I need to do is before I run another command, to do a right mouse button cut. Now I can cut a portion out. So I'm going to move my mouse up to here. Make sure that the line segment is highlighted, not the arc. Select there. I'm going to cut over to here. That's what I really wanted to cut out. All right, that's better. Right mouse button, done. I could also add in an assembly, basically the same thing. Add line. Just make sure my options window, I put that on the assembly layer, not the silkscreen layer. And I can put any other I want. Again, don't take what I'm putting in here as what you should do. You should be putting in whatever your standards are for your footprints. Just draw something in there quickly. And we're done with our assemblies. We want to use a package boundary also. Remember, package boundary is used for placement purposes. We'll go into Setup, Areas, Package Boundary. It's going to put it on the package geometry class, subclass pastebound top. This is a polygon, so I'm going to start drawing in the edges of a polygon. Notice that as I move my mouse, it's giving me a red line, like a red rat's nest almost, back to my starting point. And this needs to be a closed polygon. When I get close to where I want, I like that red line, I can just do a right mouse button, done. We'll close that in. If I turn my grids off, now you can see a little bit of the dots in here. That's indicating that that's a shape, a polygon. Maybe I want to add a height to that. So I'll do a Setup, Areas, Package Height. Command line says select or add package shape. I'm going to select on this shape. In my options window, I can give it a minimum height or a maximum height. I'm just going to type in 300 as a maximum height. And as soon as I hit the tab key, that gets associated with this package height. All right, let's see if we can save this now. I'll do a File, Save. And I have some errors here. What's going on? If we check down at the bottom, symbols missing a ref des. I must have at least one reference designator in my footprint in order to create a symbol successfully. I'll go into Layout, Labels, Ref des. I can add one on the assembly. Again, this is just a placeholder. Let me make that a little bigger. I'm just going to select someplace up here and type in like U star. It can be anything. It's just a placeholder for the reference designator. I'll also put one on my silk screen. Okay, let's see if we can save this now. Let me just do a file, save, overwrite, yes. Down on my command line, we can see that we successfully saved the dip16.dra, but it also says it's created a dip16.psm. So our DRA is basically the drawing file that we see in front of us. That's what we work with. However, the system does not use the DRA for placement purposes. It actually used a compiled version of the symbol, which is the dip16.psm. So I actually now have two files that I must keep on disk. One is the DRA that I added, and one is the PSM that is used by the placement utilities. And remember, our PSM files have to be located by our PSM path. That concludes the demonstration on how to use the Allegro symbol editor to create a footprint.